now that we have gone through the basic definition of a differential equation, it is time to look at some aspects of the definition of a differential equation. The first of these is the order and degree of a differential equation. These two terms are connected to the definition of a differential equation because they tell us what type of differential equation it is and how complex the process of solving the differential equation is going to be. Quite generally, the higher the order and degree of a differential equation, the harder it is going to be solve it. So therefore, let us look at the definition of the order of a differential equation. Well, how do we define the order of a differential equation? The order of a differential equation is the order of the highest derivative that exists in the differential equation. As simple as that. Well, what do we mean by highest derivative? Well, we know that we obtain differential equations when there are differential coefficients of certain variables with respect to other variables. So how many times what is the maximum number of times that one variable has been differentiated with respect to the other variable? That is the highest order derivative. The order means how many times the differentiation process has been performed on the one variable with respect to the other variable. For example, if I write d square y by dx square, the second derivative of y with respect to x. In this, differentiation has been performed twice, and therefore the order of this differential coefficient is 2. And therefore, if I have a differential equation containing this term, then the order of that differential equation is going to be 2, provided that there are no other terms containing higher order derivatives. The highest order derivative in this particular equation is that of the first expression, that is 2, and therefore only on this condition is the order of the differential equation going to be 2. If I introduce another term containing a higher order derivative, then the order of this differential equation no longer remains 2, then it becomes 3, irrespective of what the power is. Sometimes we can also have the differential coefficient term raised to a certain power. For example, it is 2, and for example the power of d square y by dx square is 5. Even though it is raised to the power of 5, it is still a second order derivative, right? Because the variable y and x here have been differentiated twice in the second term. In the first term, y has been differentiated 3 times, and therefore the order of this particular differential equation is 3. Very close by with the definition of the order of a differential equation is the degree of the differential equation. But before that, let's look at another example that I have for you here. We have the differential equation d square y by dx square plus 3 dy by dx plus 2y is equal to e to the power of x. What is e here? It is the base of natural logarithm, right? It's an irrational number. Its approximate value is 2.7182 and so on. What is the maximum times that y has been differentiated in this equation? As you can see in the first term, you have y being differentiated 2 times. That is why that notation, d square y by dx square. The second term also contains dy by dx. It's only dy by dx, which means differentiation 1 time. And since this is 2 is the maximum number of times that y has been differentiated in this particular term, we say that the differential equation is of order 2. So therefore, order of the highest order derivative in this particular differential equation is 2, therefore its order is 2. . Next, degree of a differential equation. The statement of the definition of degree is as follows. The degree of a differential equation is the degree of the highest order derivative. What do we mean by degree? The exponent to which the term containing highest order derivative is raised, when the differential coefficients are made free from radicals and fractions. What do we mean by that? Suppose we have a differential equation like this: d square y by dx square minus cube of dy by dx is equal to 4. Well, going back to the definition of order of the differential equation, we see that this is a differential equation of order 2. What is the power of this term? Well, since there is no actual exponent mentioned, we can say that d square y by dx square term has been raised to the power of 1, right? Since it has been raised to the power of 1, we say that the degree of the differential equation is 1. It is not the highest exponent in which in existing in this equation. That happens to be 3. But then 3 is the exponent of the first derivative. But we are not interested in that. We still look at the highest order derivative and we see to what exponent that particular term has been raised. That would be the degree of the differential equation, so long as it's a whole number, so long as it's a natural number, not otherwise, right? For example, if we have d square y by dx square to the power of 3 by 4 minus dy by dx square is equal to 0. Again, here the highest order derivative is this, and therefore the order of this differential equation is still 2. But then the degree cannot be stated to be 3 by 4. Why? Because the degree should not be a fractional number. So what do? We make certain modifications in this differential equation such that the 3 by 4 fractional exponent gets removed. d square y by dx square to the power of 3 by 4 is equal to dy by dx squared. Now, in order to remove 4 from the denominator of the exponent, we have to raise both sides of this equation by 4. So with that, we get d square y by dx square cubed is equal to dy by dx to the power of 8. And now, as you can see, the second order derivative has exponent 3. So 3 is a whole number, it's a natural number, and therefore now we can say that the order of the differential equation is 2 and the degree is 3. So this has to be kept in mind, that the exponent of the highest order derivative while finding out the degree of the differential equation must not be in terms of radicals, that is, it should not be in terms of fractions. Alright, in terms of examples on degree of a differential equation, let's go back to an equation that we wrote earlier when discussing order. D cube y by dx square raised to the power of 2 plus d square y by dx square raised to the power of 5 plus ky is equal to 0. Here the order, as we mentioned earlier, is 3, and the term containing this third differential coefficient, third order differential coefficient, is 2. So therefore we say that the degree of this differential equation is 2, even though the highest exponent overall in this equation is 5. But then that is the exponent of a lesser degree coefficient. Therefore, highest degree coefficient is the first term and it has been raised to the power of 2. So therefore the order of the differential equation is 3 and its degree is 2. Alright, now let's look at another example before we move on to a proper question on finding out order and degree of a differential equation. Consider the differential equation x times the square of d cube y by dx cube plus dy by dx to the power of 4 plus y square is equal to 0. So you would be able to tell right away by observation that highest order derivative is the third order, and therefore the order of this differential equation is 3. And this term containing d cube y by dx cube is raised to the power of 2, therefore its degree is 2.